Laws of motion. It was presented by Sir Isaac Newton in the year 1686. He presented three laws of motion. So let us go through all those laws one by one. So here is your Newton's first law of motion. So what this law states? This law states that a body at rest or uniform motion will continue to be at rest or uniform motion until and unless a net external force acts on it. So basically this is your first law of motion. Suppose a block is kept on the floor. It will remain at rest until we apply some external force to it. Also, we know that it takes us more effort or force to move a heavy mass. This is directly related to a property known as inertia. This law is also known as the law of inertia. So, putting Newton's first law in simple words, a body will not start moving until and unless an external force acts on it. Once it is set in motion, it won't stop or change its velocity until and unless some force acts upon it once more. So, this is basically your first law of motion. Here we have given an image where a block is placed on the floor. Now let us examine the forces acting on the block. The only forces acting on the block are the force of gravity and the normal reaction by the surface. There is no force acting on it in the horizontal direction. Since the forces in the vertical direction are equal to each other in magnitude, they cancel each other out and hence there is no external force on the block. Since this block is at rest, we can say that it confirms Newton's first law of motion. So now here in the image you can see the force of gravity. Here this blue arrow is marking the force of gravity and the red arrow below is the force of normal. So what is a normal force? It is an electromagnetic force and always acts perpendicular to the surface of contact. So here these two forces are same. That's why they cancel each other out and hence there is no external force on the block. Since this block is at rest, we can say that it is confirming Newton's first law of motion. So, the summary of the first law is objects at equilibrium. That is the condition in which all forces balance. We can call it equilibrium. So, objects at equilibrium will not accelerate. According to Newton, an object will only accelerate if there is a net or unbalanced force acting upon it. The presence of an unbalanced force will accelerate an object, changing its speed, its direction, or both its speed and direction. So this is the summary of Newton's first law. Then your second law of motion. The first law has already given us a qualitative definition of force. Now we are interested in finding out its magnitude. According to Newton's second law of motion, the net force experienced by a body is directly proportional to the rate of change of momentum of the body. So let us know how this rule applies. So, the second law states that the acceleration of an object is dependent upon two variables, the net force acting upon the object and the mass of the object. The acceleration of an object depends directly upon the net force acting upon the object and inversely upon the mass of the object. As the force acting upon an object is increased, the acceleration of the object is increased. As the mass of an object is increased, the acceleration of the object is decreased. So now you are clear about the second law. So mathematically it can be written as F, that is the force, directly proportional to dP by dt. So here dP by dt is rate of change of momentum of the body. So let the external force be F, initial velocity be u, final velocity be v, the time interval be t. So here p1 will be your initial momentum, that is mu. So here mu is your initial momentum. P2 be the final momentum, that is mv. So here mv is your final momentum. So F is directly proportional to mb minus mu, that is the total rate of change of momentum, mb by mu divided by t, total rate of change of momentum of the body. So force is directly proportional to the rate of change of momentum of the body. So F directly proportional to m into a, where m is the mass, a is the acceleration. So F equal to kma, where k is the constant of proportionality and it comes out to be 1 when the values are taken in SI unit. Here the final expression will be F equal to mn. So this is the formula for the second law of motion. And lastly, Newton's third law of motion. So what the third law of motion states? Every action has an equal and opposite reaction. This is your third law of motion. A force is a push or a pull that acts upon an object as a result of its interaction with another object. These two forces are called action and reaction. So here two forces are acted upon. One is called your action and another one is your reaction. Let us give some examples of this third law of motion. While swimming, we push the water backwards and the water takes us forward. This is an example of third law of motion. So here we have given an image where the man is jumping out of the boat. So when a man jumps out of a boat to the bank of the river, the boat moves backwards because the action force that the man is exerting on the boat with his foot enables the boat to move in backward direction, and the reaction force that is exerted by the boat on the man in forward action allows him to move forward to the bank of the river. So here the action force is the force that is acted upon the boat by the foot of the man, and the reaction force is that of the boat that forces the man to reach the bank of the river. So here is an image of launching of an rocket. So I have a tricky question for you. How the rocket is able to accelerate in space when there is no air in space? So how is it possible for a rocket to accelerate in space? So when a rocket is launched, how they accelerate in space? That is my question. There is nothing for rockets to push off in space. At least nothing which is external to the rocket. But that's not a problem for rockets. Rockets are able to accelerate due to the fact that they burn fuel and push the exhaust gases in a direction which they wish to accelerate. So this is the reason why rockets are able to accelerate in space. So guys, we have studied about various laws of motion. Thanks for watching us.